Welcome, everyone. I want to thank you for taking the time to be here. My name is Alicia Robles, account manager at Astay Systems. I'm glad to see many familiar names here. Today, we will talk about digital twins for mining operations, led by our CEO, Fernando Sagastegui. Fernando is a mining engineer with more than 10 years of experience in different world-class mining operations. Some recommendations before we start the session. Please turn off your microphones to avoid interruptions. And feel free to type your questions or raise your hand if you want to speak. Fernando, please, you can start.
Great. Thank you very much, Alicia, for the presentation. Hello, everyone. Many thanks for your time. Today, I'm going to give you a summary of what is our innovation, digital tool for mining operation. This is an innovation for transforming the mining industry. Feel free to ask any question while I'm explaining. You can put them. You can write your question in the chat. And after I finalize the presentation, we can read it, and I will be very happy to reply your questions. The objective of this presentation is to understand the potential use of a digital twin in a mining operation. What we have how we have advanced so far until now, developing this technology in Astay, and what are the potential uses of this kind of technology in the mining industry. Thank you very much. First, I'm going to explain you a little bit about Astay. Astay, what is the objective of Astay? Okay. Perhaps I'm not showing my screen. Wow, I forgot to show my screen, to share my screen. Okay. Excuse me. Please confirm me that you can see, you already can see my screen.
Yes, we can see your screen.
Great. Excuse me. I forgot to share my screen. Okay. I'm going to present again. Okay. What is the objective of all the products and services of Astay? Astay products and services aim to transform the mining operations to become safer, more efficient, and more productive. This is our objective. All of our products are that objective. We are trying to improve the efficiency, the safe and productivity in the mining operation. A little bit about Astay. We are a software technological company specialized in the mining industry. All of our solutions really leverage the data and transform it into a fundamental part of a decision-making process. We have a presence in some of the most important mining companies in the world, like Anglo American, Gas Minerals, Hudbay, in the mine operation of Constancia, Minsur in San Rafael, for example, and other mining operations, and Antamina, among others. We work for Gas Minerals, for example, in the mine operation of Boshakal, which is in the Middle East. I'm going to start with a question of what are the current needs of the mining industry. Each time mineralization becomes more complex, only operating mine each time mineralization becomes more complex, only operating a mine becomes even more complex. The grades in the mineral are getting lower. It is almost the same situation in the majority of the mine operation. New contamination are added to the equation. In addition to all the problems that we already have in the mine operation, we need to add the variable of new contaminations, for example. In my experience working in gold and copper mining operation, mineral resources are continually scarce. Although that this is an intrinsic characteristic of the mining industry, because we extract a mineral with high grade in the first periods, deferring mineral with low grade to the latest years, affects tremendously the mining industry business. So each time obtain less product, but the cost is the same, or even worse, the cost is increased. No, it could increase continuously. All these challenges make decision in the mining industry become more complex. Each time become more complex for all the different variables that affect internally and externally the mining industry. And we need to handle those kinds of variables in our daily activities. Some of the needs we start by summarizing the current needs in the mining industry, and some of them are lack of mineral resources. It is not common to discover new big ore deposits, and it's even harder to get the operation phase. As we know, in special today, it becomes more harder to get to that phase. Each time become more complex, and all the operation that we already have, it is necessary to be more productive, to be more efficient, because it is possible that in the future, not necessary will be open more mining operations, and especially in open pit. Also, other need is the lack of skilled professionals. All of us know that the combination of each technology with a mining business has a big potential to boost the efficiency in the operation. But at the same time, it is a challenge, because we need to find or train the specialized personnel, which is very difficult and takes time, which is the factor that any of us we have. It is important. It is very difficult to find those kinds of profiles, especially nowadays. Compliance with the production rate. To obtain the maximum value from ore depends on our capability to reach the specific configuration of parameters involved in the production. For instance, the ore characteristics are sent to the processing plant due to material blending. Okay, it is each time become as I said before in the previous slide. Each time become more complex the mineralization. In sometimes even we discover new minerals while we are mining in the operation. Even all of us, we know that in some operation they have their own mineralization specifically for that mine, right? Even in some cases taking the name of the mine operation. Information is not integrated, which is in fact, this is one of the most common states in the mining operations. In fact, at the same time, we have not yet taken advantage, and for that reason, we haven't taken advantage of new technologies like advanced analytics, which are capable of boosting efficiency, safety, and productivity in mining operation. The maturity of the digitalization, the digital maturity in the mining operation are very variable, very variable. And depends of different factors like the size of the mine operation, the state of the leaders, if they already know or they are awareness about the potential of these kinds of new technologies, the investment, the life of the mine operation, those kind of factors affect a lot in the integration of the information. All of us, we know that to integrate the information is very helpful. It is the key factor to take advantage of the data, to really obtain value from data. But in some cases, the integration of data, the integration of due to the information is not integrated, that affect in the process to obtain that, to extract that value from the data. I know in order to improve our mining operations. Thus, the current needs are related to how to overcome this new scenario, maintaining and improving the efficiency of the operation. In the next slide. Now, so what is digital twin? No? a little description, a little concept about a digital twin. A digital twin is a digital representation of physical object, person, or process contextualized in a digital version of its environment. Digital twins can help an organization simulate real situations and their outcomes, ultimately allowing it to make better decisions. It is the representation that we need to evaluate all the operation, all the system, understanding how, in which extent the changes in the inputs can affect the outcomes. Data twins are linked to real data sources from the environment, which means that the twin updates in real time to reflect the original versions. Digital twins also comprise a layer of behavioral insights and visualization thereby from data. In my opinion, as you can see in the slide, the most important characteristic of a digital twin is the future of what if. That is the cornerstone of the digital twin, and this is the base of and this feature is based on data analytics. The possibility to understand what happened if I change some of the variables that affect and some of the variables that are involved in the mine operation, in the mining system, in what extent, in which measure can affect the results, trying to understand which is the better configuration that that we can obtain the best value, the maximum value of the mine operation is so important. It is essential to understand the potential of our mining operation. Even that happened, only talking about a little bit additional about some of this situation, of this characteristic. Even in engineering, it is very common that our customer asks us if the possibility to evaluate different scenarios, like the sensibility analysis, modifying the factors that affect the process. In mine planning, for example, modifying the size of the phases, modifying the sequence, the rate of extraction, or the rate of processing, the number of trucks, the size of the plant, and other different factors that affect the process. This is almost the same, but in this case, it's exactly in the mine operation, the day-to-day, the daily activities. How can we improve how can we enhance the efficiency of the system, which is the key in the digital twin. Digital twins can result in a significant improvement in the ore quality, for example. Simulating the product through the mining operation process make it possible to identify flaw in the operation more early. For example, the possibility to avoid the contamination of the material with waste, with other materials. For example, to contaminate the mineral with in a gold mining operation, to contaminate the mineral that contains gold with coal, right? With coal or other contaminants, or in a copper mine, which there you have a mineral with high grade of ore, but due to a lack of monitoring, of control, can be contaminated with waste or material with lowest value, with lowest value or with lowest grade, reducing the grade of the material which will be sent to the processing plant. It is very important to know that the digital twin can monitor at real time how the performance of the operation. Okay, I'm going to explain a little additional on the next slide. So what are the main features of the digital twin? For example, the first is the virtual mine representation. what we have even in our solution. The virtual mind representation is the possibility that you can see the topography, how is advancing, how is progressing, the mining, the destruction of the mining, destruction on the mining fronts, how is changing the topography while the shovel is extracting the mineral, is advancing. It's very important to have the possibility to see, to analyze that virtual representation, how the trucks are moving around into the haul roads. Okay, and identifying that in some segments, the congestion is increasing, or perhaps to identify other possibilities. The second is the real-time data integration. No? This is other main feature of the digital twin. Even without the data integration, it is impossible to have a digital twin, because the digital twin is fed by the data from the systems, from the system that are involved in the mining operation. Even, for example, in our experience, some of the main activities that we have is to integrate the data from for example, systems like a fleet management system, for example, the mine planning software, or the processing plant software, data management, or systems in systems specialized like for drilling equipment, okay, and maintenance. The integration is key is essential in the data twin, in a digital twin. Interoperability with existing system, which is important, as I said, it's important that the possibility to operate with different systems, to integrate, to interact with the system with the existing systems in the mine operation, in the operation. Simulation and artificial intelligence for analysis and forecasting. As I explained before, the possibility to analysis what if, no? What if, but that to evaluate that, to have that feature, it is based, the what if is based in the simulation of discrete events. And the application of different algorithms of artificial intelligence to make a forecasting how would you finalize, how will you end it up at the end of the shift. Okay, it is the application of two of the simulation and the artificial intelligence, and also, for example, the data-driven decision support. Okay. Based on the information that what I explained, the other process, you can support your decision-making process. You can really make your decision based on the information, but without now it is some of your decision, the majority of the decision are based on the information, but the biggest step is that you can have those insights in real time without the activity of, which is really time consuming, of to collect the data, to in some cases manually, to collect, extract the data, to consolidate, to processing, to storage the information, to process it and consolidate the information, to start the analyzing of the information. In this case, it's different. But with the digital twin proposes to have those information at real time, because the information is connected, the data sources are connected, are integrated, and exists an infrastructure able to process that information in real time, trying to give the user the possibility to analyze in real time the information and and to help him to support that the decision making in that information. Okay. In the next slide, why should we implement it? Because some of the main reason that we need to implement a digital twin is that, as I explained at the beginning, each time is becoming more harder to operate a mining operation. It is becoming more difficult to find all the new deposit with high grade that for the common and normal for common and normal operation of the mine. It is each time you are expending the same amount of money, or as I say, increasing the cost, but you are producing less. For that reason, you need to, and each time the mine operation becoming more weak about the changes and regarding in front face the changes in the external factors like changes in the prices, in the increments in the supplies that can affect the supply chain, the supplies of the mine operation can affect the results, the economic results of the mine operation, and in some cases, in the past, some of those operations that are weak in front of that kinds of variation should be closed the mining operation because they weren't able to continue operating at that level of prices of cost, operating costs. Okay, the digital twin really gives you the take advantage to create competitive advantage compared to other companies trying to get the maximum value in that moment, the maximum value of the ore that you have in your mine operation, which gives you the possibility to increment the product, the productivity of your mine operation to have a really to have a great and a good management of your assets and obtain the maximum value of your investment, the investment of the mine company. Next, for example, some of the benefits: the resource management, improvement in managing material resources such as equipment, optimizing its use and reducing cost. Talking about the system integration, allow integration of various systems, mine and plant, and data for a holistic view of operations. And third, the customization and scalability, the possibility to adapt to the needs of each mine and scale the system according to the specific needs of the mining operation. The innovation and development promotes innovation by providing a testing environment for new technologies and processes. It is the fourth is some of the most important. Talking about in specific the fourth benefit. In fact, the mining operations in Peru are in my opinion, are on the top in technology, are in the top of experience, in technical capabilities, and that implement of this kind of technologies, which some of the majority of mining operations, and especially the bigger, are in their plan to implement this kind of technologies, and that can produce a big step on the development of this kind of technologies to create an innovation based on those operations. For example, for that reason, I explained that this factor is so important, because the mining industry can boost, can enhance, can boost the innovation in the mining industry with investment, with a possibility to test, and especially in Peru, that we have some of the some of the most important mining operation worldwide. What solutions are currently available? I searched that in fact some of the mass the mining industry is some of the one of the industries which are trying to advance or are behind, for example, the other industry like factories, like factories of automotives, like factories of chemical factories or others. In fact, the digital twin is widely applied in those kinds of industries. For example, in factories, as I explained, in the designing of new infrastructure, the construction, and other industry. But the development of digital twins in the mining industry is behind compared to other industry. But I'm sure that in the next decades, taking in account or facing the new challenges that I explained, I'm completely sure that development, the implementation, the application of digital twins, it should be the norm. I'm sure that it should be the norm because there will no other way to maintain the same level of production, to maintain a good to continue having or producing competitive advantage compared to other mining operation. I'm completely sure. And for example, in our case, we have developed in Astay, we have developed a data twin. Data twin is our product. What we have developed is a digital data twin is a digital twin for mining operations that can analyze, monitor, control, simulate, and generate operative scenarios in real time, enhancing decision-making process to optimize the efficiency and productivity of all the mine operations. This solution has been developed integrating the main areas involved in the mine value chain, like mine operation, geology, mine planning, maintenance, and processing plant. This is based on an integration of systems, as you can see on the slide, simulation and predictive models, and intuitive interface. All the above with a solid knowledge of the mining business. In fact, after we look for other digital twins, we found some other companies, but in our opinion, are advancing in that direction. But we are our objective is to advance specifically in the advanced analytics, which is the first goal. This is the objective. In fact, this is what we really have and our competitive advantage with other products. Okay, I'm going to explain more in detail in the next slide. For example, the keys productivities to increment the productivities, to the capacity to removal of information silos. Also, the impact on the organization, the implementing of a digital twin can impact and a big impact on the organization because that will have the availability, the possibility to help the user, the supervisor, to base their decision making in the information from the digital twin in real time. Also, it will be all other technological challenges. In this slide, you can see the three main models. As I explained, that 3D visualization, as you can see in the first square, the first chart, the 3D visualization. Using digital twin, you can see the mine in 3D. This is a really engine which works in the cloud. We have all of our solutions are developed for cloud. We really trust that in the future this will be the first technology applied in the majority of industries. The second model is the business intelligence. We use the information integrated after the integration of the integration of the data. We use that data, we use that information to try to show the user the key values, the key values that the user needs to take decision. And the third model is the business analytics, in where the main factor is the possibility to simulate. We're not talking about only what we found, that we are analyzing what happened. No, what will happen in the future, using the prediction, using prediction algorithms, optimization algorithms like dynamic simulation. This model is the sense of the digital twin. The main objective is allowing the user to predict and improve the future outcomes, thanks to the discrete event simulation and optimization algorithms. This is, in my opinion, as I said, this is the first or the key factor, the key model of a in general of a digital twin. In our cases, of our product data twin. I will explain in detail more in the next slide. In this, for example, you can see what we have developed in the 3D visualization features. For example, in the first chart, you can see the visualization in real time of the operation. After we connect the different sources in the mine operation, we are able to show to put that data in the database engine, in the database of data twin in real time, and put that information in our visualization model. As you can see in the first chart, in the first chart, you can handle, you can modify, you can move the center, you can move it from different mining fronts. Okay. The second is the visualization by layers and of 10 geology block model variables. In fact, it is very helpful. Some of our clients have taught us they have said that in some cases, so other the competence, other products have not that possibility to be able of analyze only putting upon the click.
They won their third straight championship. You know, everybody loves Shaq. So where did you get it?
It seems that someone have the microphone. Okay. Talking again about coming back to this point is that the possibility to analyze only putting the cursor and above the mining block is very helpful. To analyze different variables is very helpful for the user. For that reason, we provide with that characteristic, with that feature. The third is the alerts from congestion and failures in GPS equipment. For example, that is very also helpful for the supervisor, for the managers, even the chiefs, to identify in which segment the haul roads are incrementing the congestion, as the digital twin is constantly evaluate the reality which is based in a server, as it works in a server, continually extract that data and process it to evaluate if someone what we can set is passing of a limit level. For example, the congestion, the queue in a mining front, or I don't know, perhaps if the cycles of a track are longer, are increasing, or perhaps the productivity decrease at a minimum level. We can analyze that information, but in real time. The server continuously extract and run and process that data, trying to obtain that insights and give that insights to the user. Okay, the fourth is the equipment monitoring more than one screen. In this screen, you can see what we thought in that when we designed this characteristic. Some of our clients told us that it is important to put it that this screen as the digital twin works in the cloud, we can open up the digital twin in different main areas. In some cases, that for example, in mine operation, want to see only the shovel one, or perhaps in mine planning they want to analyze how the shovel 2 or 3 are advancing, and the possibility to put those two screens in one, two images, two mining fronts, to analyze two mining fronts in one screen is very, very helpful for the user. The fourth is the drilling monitoring and control, which is the possibility as I work, for example, I work as a short-term mine engineer, short-term mine planning engineer. I really know how important it is to monitor and control the advance of the drilling machines, because of that advance depends the movement of the drilling machines, or the blasting of a project, which will give us the possibility to obtain mineral to feed the shovel, okay, and to reach the goals, to reach the target, to obtain to fulfill the mining plan, okay. This is the 3D visualization features. For example, in business intelligence, in the business intelligence mode, we have monitor the main key performance indicator of the mine and processing plant. Also, the mine has the drilling, blasting, loading, and hauling process. We already have joined all of those areas in this screen, in this model, trying to even working together with the user to identify which is the best, because we already have developed many different KPI factors, but we organize those factors depending of the user. If the user believes that it is more important to see that the advance, the progressing of the drilling equipment, we work with them and move the charts, the graph, trying to give them what they really need. I want to say something about that. We have developed data twin completely. All of our team had developed the data twin from the scratch, from the designing, the conception of the digital twin, until what we are offering to the mining industry, and a complete product with the 3 models, from the visualization to the advanced analytics. In other words, we have all control on the product, and we really reply the requirements of a user very quickly, which is very helpful for a mine operation. We know The third is in the processing plant, we have the crushing, throughput, and stockpile level. For example, you can put that information there. That depends, as I said, that depends of the user. The detection of potential failures of the equipment also is very important. Continuous updating of charts with real-time operation. As I said during the shift, information during the shift. As I said, as the digital twin is connected with data from different sources, it's integrated. It is easier to put it to the database of digital twin of the data twin and to process it, trying to obtain the key insights, which are really helpful for the user. The third is the business analytics. We know that I know that we are in the close nearly to the time. And the business analytic model we have, and this is as I say, this is the key factor. This is the key model. The end of shift production forecasting. This is possible thanks to the data flows continuously from the mine to the digital twins database in the cloud. Okay. The integrated analysis of mining scenarios aligned with the short-term mining path plan. Identification and prediction of materials through throughput per bench by hour. Recommendation of blending based on the characteristic of the material, and the spatial compliant calculation, the estimation drilling time. And we know normally when we want to know, when we want to calculate how many time need the drilling machine to finalize the project, the digital twin helps you in that. If you upload the project with a number of drill holes, the solution can measure how long time lasts, how many time remains to finalize the blasting project, which is very helpful. As I say, trying to understand if you will be able to blast the project and feed the shovel, and that, as I say, that help in the fulfillment and to fulfill the requirements of the mining plan. The estimation of drilling time, as I say, detection of bottlenecks, operational deviation, and congestion. In this slide, I want to see something. I want to explain something. As you can see in the shovel, around the shovel exists squares of different colors, which is really revolutionary for our tool, because in this possibility is not, you cannot see this kind of feature in other tool in the mining industry. That really allows that the shovel knows which material, how the tonnage and the quality of the material that they have in the mining front. That really help in the possibility to create mining plans automatically. As we know, in some cases where after we send the mining plan to the operating chief, one hour after, some cases the mine operation changed, and there is no the factors, the scenario that you have at the beginning of the shift have changed, and you need to adapt your mining plan to that new scenario. In the majority of cases, that is not possible, because there is no enough time to modify the mining plan and other factors. For that reason, we have developed the data twin to evaluate automatically different scenarios. But the key is to know what is the material available in the mining front, in front of the shovels. That algorithm is revolutionary, and it is a key. There is a cornerstone in our solution. The last slide is how it works. Only to explain a little bit about how it works. Data twin. Data doing integrates the main areas and systems involved in the value chain of the mining process, like the fleet management system, drilling fleet and blasting system, mine planning software, geology data, maintenance, and processing plan information. The information goes directly to the digital twin database in the cloud through the models and algorithms obtain the main data twin features, like, as I said, 3D visualization with real time, simulation of mining plans, recommendation to optimize the blending, industry forecasting, spatial compliance, alerts for operation deviation, high precision, failures, and congestion in the haul route. Also, the assessment of the unplanned changes impacting the outcomes. As you can see, data twin is fed by the information from the systems involved in the mining process. For that reason, that can help the user to really understand the current situation of the mine operation and to make better decision based on the data, based on the information available. This is the final slide. Thank you very much for your time. If you have any question, I will be happy to reply.
Thank you, everyone. Please, if you have any question, you can raise your hand or write it down in the chat. We will be sharing the record of the webinar in chance you want to see it again. And please feel free to make any questions. Well, if there are no questions, thank you everyone for your time, and we will see everyone soon. Thank you, Fernando.
Thank you very much.
Thank you, everyone.
Thanks a lot. Do you have any question? You can put in contact with me. You can write to those emails in fsagasti or @astaysystems.com. Or perhaps to write to me by LinkedIn. Thank you very much.
Thank you, everyone. Take care.